I really like the idea of going a little bit deeper on the topic of performance testing and performance in general, something we don't usually do so much on the OTC. And that's why I was excited to actually have you here. And not talking about, again, load runner and stuff. We need to talk about that. I didn't know that you were in the load runner team. I was on the test director and QTP, but we'll talk about that later. And observability in general. So Mark, without further ado, the floor is yours. So let me just stop sharing and you should be able to do it yourself.
Okay, and I should be able to share PowerPoint slides with you.
I hope.
Woohoo!
There you go. Yeah, it's a little bit late to save your seat, but you can actually log in.
No, I just, I throw that up there and, that's fine. But save your seat. It's happening now and you could show up later.
Sounds good.
Beautiful.
Okay.
All right. Welcome, everybody. This is a fantastic chance to give only the second time I've actually revised and talked about observability. This is a faddish thing called observability and how it relates to performance in particular. So if we put a lens on performance, meaning the temporal aspects of our work and the physical resource usage over time, we're going to think about what does it mean to make things observable, and also maybe debunk a few myths about, what is this sort of new term that we see as observability. But that's to say this is something new, which is not. As long as we've been able to have eyes and a sense, sight as a sense, and be able to cognitively make sense of those things, we've been observing all sorts of stuff in our environments. But if we back up just a little bit within the age of industry and technology, we start, if you will, observing things in a car, in one of the first automobiles, which was delivered without a speedometer. Nothing like having a good car analogy, but vehicles are something we can relate to because we can command a machine on what to do. And a lot of what we do in testing is to make sure that machines operate properly. And there's a lot of things involved in terms of our use and human factors to make a car go. So if we think about sort of the first points of being able to observe in an old automobile, had no speedometer whatsoever. So you could not observe how fast you were going. The nice thing was there were no speed limits and or police to stop you. You would just crash and die or kill livestock or drive off the road and ruin your car or whatever. I mean, there was just no idea because we were, horses could only go so fast. That was a speed limit. But now we had cars and they kept going faster and faster and faster. So somebody decided, you know what, we probably need to figure out, maybe for performance reasons, some of the sports cars that you saw in competitions, they wanted to, they wanted more instrumentation about what it is we are, what's the RPMs on the engine, and particularly how fast we were going. So if we went into a turn too fast, we knew we could slow down a little bit before we went into that turn, and we could keep safe and the machine would keep operating successfully. Then, of course, we innovated the idea of a speedometer, and suddenly it becomes digital. Now, but behind it, it might be completely mechanical. There's still a cable attached to a gear inside the transmission, the gearbox, and the wheels are spinning. And so you could see digitally how fast that was happening. But if you've ever seen a digital speedometer that's estimating things, if you live in places where there's lots of snow and ice, you hit the gas and the wheels spin, but the speedometer still says, maybe I'm going 20 miles an hour, but those wheels are going like 100 miles an hour, or the vice versa, you'll see that. So good idea in terms of, this speedometer is kind of sexy and cool and we can do digital things with it, but it's not very accurate how we're doing some estimations in terms of, are we really observing how fast those wheels are actually spinning? We've kind of lost something along the way from the mechanical mode. And then somebody said, what really matters is not just how fast we're going, but where we're going and what's our estimated time to get there. And we invented this thing by throwing, little robots up into outer space and rotating around the planet or stationary, and we come up with GPS. So now I don't really even need a speedometer. I can have the signals from outer space tell me how fast I'm moving through space and time on the roadway, and it can tell me where the next coffee place is so I can fuel up and have more caffeine to keep driving all night. So there's a great optimization. Then somebody said, you know what? What's great is we have, the physical realm of a speedometer. We have this digital capability to turn it into the sensors, turn it into digital information. We can correlate that digital information to global position satellites and download maps from the internet. Let's get totally mobile and let's start making it on my phone so I can get into someone else's car. I can make an app for that. So now we've got full internet capability plus the GPS capability with live maps, so we can get updates on traffic, we can get updates on construction, all sorts of things. Wow, we've taken this little idea of a speedometer and it's come all the way this far to make observability. I can observe how fast I'm going. I can do all of these extra cool things with it. And the last thing we've done recently in this, I'll say in the last 10 years, is make things shareable. We have the social aspect of our driving. And now all these other people in Waze or whatever traffic app you use, you can see other people. We can tell each other, hey, there's a carcass on the road, there's a construction, there's an accident, there's rerouting, and we can get points. We can share, hey, everyone, watch out for this. Hey, everyone, they're out of donuts. Don't go to this place. Go to the other place for donuts. So we socialized the idea of observing speed response time. And that, to me, is just indicative of how observability has evolved, even for computing. Now, the one thing that if you don't do any of that stuff, if you don't observe how fast you're going, what about observing capacity and volume? Now, we've been doing sort of monitoring, which has kind of become kind of a negative word. Oh, you're just doing monitoring. You're not good enough. I know, you're just doing monitoring. You're not doing observability. But the truth is, we observe things like stress or load. So I should give a trigger warning. This is a horrible accident of a collapsed bridge in our aging infrastructure. But we have sensors and we build bridges that are known to support certain capacity and certain volumes. And the idea being that when something horrible is about to happen, or when it's before it happens, that we have sensors that can tell us, hey, not just how fast you're going, but here's the amount of load and capacity. Are we observing load and capacity at volume? And this is where I think the evolution of observability starts to become social and starts to be sharing. But we're not quite sharing everything there is that we've traditionally, I'll say traditionally in a good way, tested and been responsible for. How much load can the system handle? We're doing proactive load testing and performance testing before we go live or put people at risk, and that's an important thing. So I have some guiding principles when it comes to kind of understanding observability for performance, and particularly performance in computer systems and or larger networked systems impacting the business. And there are 5 guiding principles. The first is, obviously, we talk about monitoring. We can monitor stuff. We make things visible, right? Make invisible measurements, like the speedometer. The speed you were going used to be invisible. We put a speedometer on the dashboard, and now it's visible. Great. So it have to be visible. That's the first guiding principle. And almost every tool that has some kind of monitoring, every operating system has a utility that can tell you CPU, disk, memory, network. Now we can instrument browsers. We have rendering times. We can see application profiling in the stacks. So we can make a lot of those things that are happening inside a computer very, very visible. Storability is the other thing. If I want it to be observable, I don't want it to, like a speedometer is just observable right now, and then right now, and then right now. The interesting thing is to say, well, what happened? Oh, well, something went bad. What happened over the last hour? So I need to store those metrics. So to make things truly observable, I need to observe them not just in the context of time for that same measurement or correlating it to other measurements. So storability, which is technically, according to spell checking, not actually a word, but I made it a word now. So you want to save those measurements for future calculations and or contextual understanding over time. The other thing would be adjustability. And can you imagine if we had the Mars rover what are the Mars lander, I think, was the classic one with a mismatched bug in the software. And we could say, oh, you know what? We're miscalculating that according to the measurement system. Let's go in and adjust that so that our trajectory and calculations are correct. A lot of people in the older days of testing used to be your test result is your test result. You don't go in and you mess with a test result. You don't flip something sort of illegitimately or cheating to go from fail to pass and, oh, it passed, and then everyone's going to find out. We just don't do that anymore as much. It's more of a danger to not be testing than it is to adjust intelligently certain corrections to measurements that we know are inaccurate, where it's like, well, that measurement is consistently off by 5% because of this other thing. Let's make an adjustment to our things we're observing so that we can make an easier understanding. Now, we still want to make a note that we adjusted it, but adjustability is something I see within all the conversations about observability. Extensibility, well, we've seen this forever since systems have been talking to other systems or code has started to become more open. We want to be able to relate our measurements to other measurements, so we want to be extendable. I can take the information from the browser, export that into a HAR file, correlate that to some measurements from the app server, profiling the same API endpoints. Now I can start relating two pieces of the system. Oh, I know there's a stored procedure. Here's a tag that maps all the way through that. If I think about open telemetry we'll talk about, I can have a reference tag that tells me that's the stored procedure that relates to this method, that relates to this endpoint, that relates to this API call, that relates to this component, all the way along the stack. So I want to extend that, and that's an important part. And the last one, as I mentioned before, shareability. If it's good that I put all this wizardry together and I can observe and measure and monitor my systems, guess what? That's good for me. But my job is to make sure all of us as a team, as a company, as an organization are successful. So if I can share a particular measurement in its context because I stored the results and I adjusted things to make sure that we're looking at it the right way according to the problem we're trying to solve, and I brought in some other information, if I can share that information with my testers, with my lead developer, maybe with management if there's a business risk of some kind or some other mission critical thing, shareability is also very important in terms of communicating what the heck do all these measurements mean. So let me debunk a little bit in terms of the novelty of this whole thing, observability, which you'll see as this hashtag O11Y, which is kind of accessibility has its hashtag A11Y. Now you see observability Ollie, A11Y, which is great. Some of the people I follow, you can go out and look at some of these names, great, fantastic people who are innovating the concepts of observability. One of them, observability must empower us to debug novel cases in production. You know, the test can be a very pristine environment as much as we try to do negative or chaos testing and those kinds of things. When you get into the real world of production, crazy stuff happens. So Liz Fong Jones does a great job of talking about you need to feel empowered to do debugging. I have all the information I need to solve a problem and share how we're going to solve that problem and get it done quickly in production, something novel, something we didn't expect. Something that we didn't anticipate, which is good. Chris Bailey talks about, can I ask questions about my system from the outside and understand what's happening on the inside? Without having to ship new code, change a config value, restart it, whatever. I'm not sacrificing the system state in its error state so that I can understand what actually happened, what resources were at play, what functions got called, and can I see tracing within the system calls happening on the computer at that time. But I love the outside-inside concept. Can I like a speedometer, can I see what's happening on the inside for let's say speedometer, RPM? I can't count how fast the engine is going, but I can make with an RPM gauge, an RPM gauge, I can see how many revolutions per minute are happening inside the engine. Fantastic analogy. Charity Majors also works for Honeycomb. It's about complex systems, unknowns, emergent behavior, and other hard problems. So observability is like, what is the one, if you don't have observability and you're having lots of difficulty, you don't know what's going on, one of the first things that comes out of your mouth is, can I see the logs? Can I see the system? I need information, I need data. And so that seems to be a core piece in terms of the novelty around observability. Now, some of the people that, like me, who have been working in systems infrastructure, and these are common things we already think, but they haven't been crystallized quite as much. Some people have, there are other thought leaders out there. Some people have more things to say, which are a little bit more trite, but I like it. Observability is a culture. We saw this with the DevOps movement over 15 years ago. You know, DevOps is not the thing you pick up like a wrench and start doing. DevOps was, hey, there's a cultural aspect to it, like how we work together, how we communicate, our attitude about how we develop code and how we cooperate with observations in production, with the operations, excuse me. I liked Ronald McCollum's monitoring is a verb, observability is a noun. And I'm like, okay, monitoring is something you do, and then observability is, obviously, because it's an ability, is describing the thing that it is, extensible to the guiding principles. Christine says software is opaque by default, therefore it must generate data in order to clue humans in what's going on. Of course, great. I also liked sort of the far-reaching projection from Peter, twilight of the experts. And this is something I'm on because a lot of people like to call me an expert. I'm legally not an expert in that way. But you know, you need that guru person that they can go in and they know all the things that are happening. And so you ever have someone that shows up like when you're troubleshooting something and go, oh, did you set the ID XYZ config to no? No, nope, set it to no, run it again. Or you're sitting on the end of a chat and it's like, hey, Tim, can you take a look at this? And Tim goes quiet for a while, like 10 minutes. And all of a sudden, the only thing Tim comes back with says, try it again. Like, you don't know what Tim did. There's some expert. Damn you, Tim. You just, what is this? I don't get it. So Peter's right onto it. The making things more transparent, more observable means the specialty black arts, dark magic, dark arts, whatever it is, that happens inside the head of a performance infrastructure guru guy person. Guess what? Those experts are no longer revered unless they can make it transparent to do what they're going to do. So let's talk about systems and testing systems to better understand observability through unobservability. So let's talk about technical unobservability. Let's say you're diagnosing a bottleneck in the system. Monitoring was turned off. The monitoring was on the wrong component. There was a new version pushed and you're monitoring the old version. You have no logs. The monitoring data itself has gaps. For some reason, you're missing 30 minutes worth of monitoring data. The log data has gaps because the same thing that knocked out the monitors knocked out the logs. The logging timestamps are on where suddenly we're looking at the wrong time zone, and any other black box you might find technically. I don't know, the wire goes into that machine and then comes out of that. I don't know exactly where that machine is. So black boxes are, you don't know what's going on there, you can't see in it. So technical unobservability is akin to any one of those anomalies, or what I would call anti-practices, anti-patterns, that work against you when you're trying to resolve a problem, troubleshoot a problem, and actually formulate a better understanding of the system that you're working with. So the opposite of that would be technical observability. Let's think about unobservability. Maybe you have all those things technically, but they're still inaccurate. Like for instance, the time zone. Another example is aggregation. If you've ever gone to somebody that says, well, we're monitoring the CPU in production, but the sampling interval is only every 10 minutes. So we take the average over 10 minutes of the individual samples. And of course, the average ends up looking a lot lower than the spike that happened for 2 seconds at 100% CPU. We have problems in production where one little component will 100% CPU, but you won't see that if you have aggregation. And then we know with APM tools, If you're monitoring a load test and they're like, well, you'll just use the APM tool, and its sampling rate is only every 15 seconds, you'll miss all those spikes. So we know that happens. That limited sampling rate combined with aggregation means you really are looking at the wrong numbers. Response time's 3 seconds. Okay, is that average? Is that the max? Is that the mean? Is that the 99th percentile? What is it statistically in terms of how that can happen? Extrapolation is another evil. So, okay, well, in the test environment, we're testing at something that's 1/10, 1x versus 10x, which is performance in production. So let's say we're testing on my laptop and I'm extrapolating to the cloud or the universe behind me. Right? That's huge. That over extrapolation means I don't really think your numbers are very accurate, right? So you may be telling me we can observe response time, CPU, number of transactions per second, but guess what? You've over extrapolated. You can't extrapolate that, and now I'm inaccurate. Even if I can observe that number, I don't trust it. It's misleading. Don't socialize it. There's also things about misleading visualizations where you'll see the y-axis will be exponential, the x-axis is not. So you could see, okay, well, we're trying to get it to fit on the graph. Well, you know what? Build a bigger graph. Don't try to cram test results into something small like a PowerPoint slide. Like, leave them in their native form in the graphing tool and be able to navigate. We can afford these giant IPS, giant LED monitors. Buy a couple. Make huge graphs. That's so you can really visually understand what's happening and stop messing around with scale or any of that kind of stuff. The other thing is instrumentation error itself. Instrumentation meaning you actually instrument the code with timers, start, stop timers within your code. We see this in performance tests, of course, but sometimes in the application of the test itself, we need the start and stop timers. And if we don't put those in exactly the right place, we'll miss out on some time. So we may come out and say, hey, the such and such transaction account lookup took N number of seconds. And I look in the back end, I'm like, there's no way. That method takes way longer than a few seconds. Well, instrumentation in the code, the developer, whoever developed or wrote the code, they got it in the wrong spot. So that can lead to inaccuracies as well. And then, of course, social in observability, meaning limited people can see the measurements. Like, we only have a license for 3 people to log into the tool that we use for monitoring. Well, how come everyone can't see? We should be able to have read-only access for everyone. Everyone should be able to see. If I'm going to send you, Joel, I'm going to send you a graph and I expect you to understand how to fix this problem, and you come back to me and say, I can't see your graph, well, that's the end of our triage. That's it. The other thing that happens, there's a lot of finger pointing at the so-called experts in the equation, because it's like, well, you're the guy that said, he or she said X, Y, and Z. Show me if I can't show you the tools or I can't share that information, it leads to a lot of finger pointing in the blind. We're groping through the dark and getting, people are amped up, they're stressed out. If only one person explains everything, from an ops perspective for observability around performance, that's a no-no. You think about development and test teams that have been doing mobbing, have been doing paired programming, paired testing. They've been collaborating in their everyday work forever. If for some reason we show up and we're like, well, you have to let me speak, I'm going to explain this to you. Instead of saying, well, let's bring a bunch of these graphs and let everyone sort of share in what their thoughts are. And there may be a very smart person in the room that can kind of lead the discussion, but our job is to facilitate understanding, not show off that we're the expert. Also, if we're socially unobservable, we don't mutually learn and understand together. Other ideas that might actually be more accurate or more correlated to the problem, it's harder to correlate that information. And the biggest one at the bottom, we can't learn from our mistakes. If we're not sharing, we're not really able to have things reflected back to us so we can learn, oh, I made a huge mistake. But if I did it in a bubble, isolated, I won't know it's a mistake until it's too late, until something really gets damaged. Observing performance then boils down to a few things. If I think about unobservability, there's the old school approach, and then there's this new thing called observability. In the old school, it's what you would expect. We're not monitoring at all, right? It's set up according to the expertise. I'm the one person that knows .NET monitoring, and I'm going to tell you the one right way. A lot of mansplaining involved. It's really kind of nasty. Changes to do more observations. We push those codes through config changes or code changes. There's a lot of data stuck in a tool, in APM. I can't share it out. And that's sort of this reactive model. We're watching what's happening, and then boom, something blows up, and so we react to it. Observability tends to be different. It's more open. It measures things all the time. We're instrumenting stuff more thoroughly and more efficiently, thankfully. We correlate that stuff to other informations. It's a very refinable model, if we think about that. And it's a very proactive model because we know proactively in development the things that are important to track, to observe, to keep, and what those thresholds might more accurately be in collaboration with operations. So, moving quickly, I want to talk about testing with observability, which is something that everyone tends to crawl out of their black box mode. And we start doing things like opening the dev tools in the browser, and we start looking at this amazing amount of profiling capability within each browser themselves to show us everything happening in a web browser, in a web app. We learn about profiling applications, either locally on a desktop or on the server. We can learn about all of that. When it comes to testing, how do we integrate and think about observing things while we're testing? The overall goal, and I'll just read this verbatim so you can hear it, enabling other people to see everything going on inside your application using tools from the outside of your application without having to stop the system, reconfigure some other tool, and recreate the original problem they were trying to understand and solve. So in other words, make it easy to operate the application. Make it easy to see what's going on. If I need to see more, I don't need to restart the app. I can just it's a built-in feature to increase the amount of logging or amount of profiling. I can use tools from the outside. So I expose information like a speedometer. Hey, engine, hey, drivetrain, give me information about how fast we're going. Give me information about the RPM, the oil pressure, the temperature, etc. So we're basically making the insides of your application describable so that when we're testing, if we're testing something over there and we're still observing something over here, it could be an interesting correlation. I went click, 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 and then I saw this interesting message go, oh, you know what? That's an interesting bug. Isn't that interesting? Now that I can see in white box mode, I can see what's happening. I can actually kind of run ahead to say, wow, if this thing were to ever happen in production, this is the follow-on remediation. So when it comes to testing with observability, it's very important to do the following. Expose all the information you can about the application. Put out timestamps, durations on any remote calls, third-party calls, like, hey, I'm going to here for some A/B testing and marketing. Hey, I'm going over there to get some data about shopping trends. I'm going over here to get the social information off your Twitter feed. Any of those remote calls where you're really important to make it observable, time spent. How much time is spent doing something? The other thing is volumes. So I want to be able to see if I really want to go get one item out of a cart, one item out of an object or the database, but really there's 10,000 database calls happening. Wow, why am I filtering all that on the app? Why don't I filter that on the database? There's some inefficiency. So I want to see if all of a sudden on a Thursday, we pushed a build and started testing and we're doing 100 times the database calls, the volume of that. Somebody pushes a really big image and all of a sudden we're loading 5 meg into the browser for no reason. Wow, I want to see volume. Make it transparent. Set some, oh, that's crazy. Listing out methods and constructors are really, really important, particularly if you're in sessions with your developers. Hey, I can actually speak their language. We can speak the code language. Hey, method X, Y, and Z, we're looking at this particular interaction, and here's what we found, something interesting that we observed. And you can show it to them. You could share it with them. Any of your entry and exits, if you have an event-driven architecture, any of your entry and exit pieces, use an instrumentation framework. The Honeycomb stuff is stuff I've been looking at recently. There's several others out there, but don't try to build your own logging instrumentation from the ground up. There's some really great frameworks out there that make it easy to do this and pull that data, make the heavy lifting, behind the boring stuff, easy to do so you can get up and running really quickly. Also think as you're testing, what are the important things that we need to expose about this particular application? Like this application we know does very large month-end reporting. Okay, that's a large amount of data and it requires ETL processing and the cube and whatever, rolling a cube, running the queries, and then the report generation takes 45 minutes. All right, what's important to that app is different than a mobile app where you're going to do really fast loading of images or scalable vector graphics. Or it's very different than just news feed tickers, streams, or streaming video. So that particular application, what are the most important things for that app that you want to be able to observe? Thinking about logs. Oh, logs. This is my new thing. Logs should be dumb. Man, logging has been around for so long, just make it dumb. Not just keep it simple, stupid, make it dumb. Dumb meaning debug mode should not be required. For normal operation, you should be able to do everything, run that application in production without having to turn on debug mode when something strange happens. Which means if you ever, debug is really for the exception case where you have to debug stuff. If you find things that within a 1 week time frame, if somebody asks for a metric that's only in debug mode, move it into normal info mode logging. Hey, that's something that we use pretty frequently. We can automate based on those logs, make them dumb. Make it debug mode should not be required for normal operation. Universally available, meaning in a simple log format. Everything from putting stuff into time series database, logging stuff into Splunk, logging stuff into the Elastic Stack, keeping your logs really simple, parsable, put it in a shardable, NoSQL kind of database. They should be universally available, so there's no super special tools. Don't put it in a proprietary format. If you have to put it in the database, try to keep it in its native format as much as possible so somebody can say, hey, here's the log messages. Keep it universally available so you can kind of move it around. The other thing is make it manageable for high throughput sites for performance. What if you've got excessive logging? We create, a gig a minute, a gig a second. I've seen really faster than that. Well, am I really building a system to make it easy to manage? When are those logs not very valuable? Where do we put them? How do we move them off to lower and lower tiers of storage, compress them and throw them away eventually? Make sure you think about the manageability of those logs over time. The other thing is you put information in your logs that are not just technical. If there's something relevant to the business viewer, there's nothing worse than going into a meeting where it's a technical person pulls up the logs and all the business people just tune out like, oh, you're doing that technical thing again, nothing for me. Well, put some names in there that say, partner call to X, exceeds SLA contract, KPI not met by N seconds, references to customer third-party calls that we have relationships with. There's one in the AppDex that we see now, if customer satisfaction gets worse. Make things in your logs that are potentially business relevant, right? Money is business relevant. So, dollar amount transactions, put those in the log. Anything to keep them interested, but also make that conversation translatable. So monitor all the things. This is a remedial course on monitoring, but you do have to monitor all the things. Monitor time spent doing anything, response times, methods, queries, IO, lookups, disk access, ping times on the network, rendering time on the front end. So you want to monitor time, and then you want to monitor volume, or I'll say physical resource usage, CPU, disk memory, network power, and cooling. Those roll right off my tongue. The core ones we usually see are CPU and memory, but also disk storage for databases, networking for distributed applications, obviously power and cooling. If you overheat your phone, if I overheat my phone, it shuts down, can't use it, can't buy any puppy dogs on the internet, can't do that. Logical resource usage, we miss that. Number of connections, number of threads, number of objects, number of rows. There may be limitations logically in the code that have nothing to do with the physical resource limits. So are you unnecessarily, you want to monitor how many threads are we using, how many connections are open. Access. So on top of that, how many sessions, how many calls per second, instances, and paths, anything that again is sort of logical, but is determinant of, can I even access the system that I'm testing? Looking at volume, number of users, number of transactions, number of third-party calls are a good place to start. And then think a little bit about, can I monitor financial cost? Is there a way to translate N number of transactions per second in a shopping cart to a conversion rate, to dollars spent? Can I actually have the amount of transactions in the log somewhere where I can see, here's the dollars per second that we're spending? Here's if you're running a charity site, how many dollars of donations have we had come in? Make them observable. It also that goes to business risk and things. And then sentiment is a big thing. The AppDex is good, but also thumbs up, thumbs down. Customers happy can be indirectly or directly inferred. Or you could say customer feedback, somebody giving reviews, hey, I didn't like this part sucked. Make those, if sentiment feedback is going up or sentiment feedback is going down, then you can also correlate that to poor performance means unhappy users. A big thing with observability in your testing is this idea of tracing. And tracing is the idea that there's an ID that propagates across the system. This has been around for a while in many incarnations, but the OpenTelemetry folks have done a good job. If we think about an individual product, a product that has evolved to be part of the larger ecosystem, I need to have IDs that can correlate where did all the data come from, where did the requests go to bring that all back and create my end user experience. So you be familiar with what tracing is on an ID. There's low-level tracing in the operating system. This is more like cross-system correlation. They have transparent, trace parent and trace state. That's important to be able to understand when we're tracing a system, that every ID has its parent and its current state as it's being used across the system. There's a provider. Where did that ID originate? Is it in my middle tier? And then I send stuff front and back from the middle tier. And then you want to include context about that trace ID for how it's being used. So usage and volume and session means what session was that transaction part of and how much activity was happening around that ID, how much CPU was used, and correlate that information around a trace ID. A given transaction went through the system to load a page, and it was really slow, and there was a huge number of rows gathered from the database. So we're using that to troubleshoot and to observe a real user finding stuff from the inside. Or you as a test, when I went through the automated suite, test case number 733 has this really bad performance. Let's go trace what's happened there. There'll be some costs. Obviously, performance-wise, there's overhead to adding trace and ID. And most of these trace systems have to be interconnected. If you have loosely coupled systems that are kind of independent, you don't see this as often. So be aware that if you're testing with an observability goal in mind, you might need to start looking at some of the tracing ID systems that allow you to do that. You can see it in a Dynatrace system. New Relic has it, I think. There's a few others. The Honeycomb stuff you can instrument for trace IDs as well. It's good to look at the OpenTelemetry stuff. My thoughts on instrumentation generally, in the old days, you didn't have that much CPU to spare. You barely had memory to spare. I/O was really slow. So adding code to spit out messages for monitoring and tracing, wow, we turn that off in production because we're starved for resources. But truth be told, we're not starved for that anymore, right? The event tracing and stuff has very low overhead, and we have a lot of excess scalability in systems and containers and the cloud and such. So manually adding that instrumentation doesn't have the cost to performance that it used to, and obviously makes it easy to spit out and make things very transparent. It does, however, add overhead to development. So they have to know where they're going to put their logging or their start and stop timers. There's extra development involved in making that instrumentation coded into the system, which is why a framework for instrumentation is really good. There's automatic instrumentation and profiling in some of the tools. You'll see it with the old diagnostic tools from HP. Micro Focus now. Obviously, the Dynatrace stuff is really good. New Relic has a bit of that. Anything that can hook in to the libraries and start automatically tracing .NET, J2E, and other Java applications is really good. So it makes it easier to see method level calls and make things more automatically transparent. Instrument in about and around all the third-party pieces, any library you're using, any remote call you're making. Usually our code that you have control over is that you're testing. We can fix that. We can do we know a lot, the most about our own code. But we want to do instrumentation, use those trace IDs around stuff that we don't control, that is outside our purview, which is really good. And then you want to be explicit about the context for each of those calls going to third parties. What was the user doing? What was the session state? What things were set certain ways? Let's actually figure that out. Exceptions under this case for instrumentation, you do not want to have exceptions being instrumented so that if you have something go into a bad state, you're making it even worse by spitting out all sorts of more instrumentation around it. I'll give a shout out again. I mentioned Dynatrace a lot. I follow those guys quite extensively, but they have an interesting white paper. You can look up their ebook, Observability and Beyond the Modern Cloud. They have 4 things that they like to talk about for automating the entire process of observing. So you want to check that out if you can. I have the link there, but just look for Dynatrace Observability Beyond the Cloud. Auto discovery is nice. Auto instrumentation, once you find the stuff you want to instrument, it'll automatically instrument it. And then as you're operating, it'll automatically create a baseline, which is great for testing. We can see what healthy looks like, so we can identify what unhealthy looks like in comparison. And then obviously with observability, as things change over time, you want that framework to automatically update the instrumentation. So they have some cool stuff happening in their world, just giving them a shout out. The last section I'll talk about and bring us home is performance socialization, this idea of observability being more social or socializing the transparency of it. And I kind of came down to 3 things that makes this whole observability stuff very, very popular. And it relates to the idea of socializing and making that opaque, dark art, magic, performance, and infrastructure stuff more relatable to the rest of the development world and the rest of our engineering world. Those 3 things about observability are: 1, there's just a backlash against unintelligent, lazy, static monitoring and logging. We're basically throwing the basic good old logging, have a nice day. There's just a backlash against doing the minimum. And I'll tell you, we've gotten really complacent with APM. I got the tool, I push the button, I'm doing it, right? And then, the business, we go off and we get distracted and we do other things. And somebody's like, oh, well, I guess I just left SolarWinds running in the background and, oh, well, So observability is reinvigorating passionately. Stop being lazy about just monitoring. Step up your game and start cooperating. The minute we start doing dev and ops together and test and all of these things connected, clearly anyone that's just kind of doing the bare minimum or being lazy about it is going to get outed. And kicked off the island. Adopting open source and open standards. Look at open telemetry in particular, which is something where the old platforms, and I say old platforms as an old guy, some of the old monitoring stuff, there was old IBM stuff that we used to use, the Tivoli systems for monitoring, HP, I forget the name, it just went off the top of my head, HP system for monitoring stuff, large enterprise data centers on-premise, there's no cloud. We were responsible for every little light and every little drive and every little CPU and every DIMM that was happening. And they were all very closed systems. And nowadays we don't do that. Massive open source, everyone's sharing the ability to monitor all sorts of stuff. And then of course, in that vein, the preference for collaboration across the entire team, except for versus some solo experience. So stop being lazy, start getting your systems to open up and share your data, and then start collaborating with the data that you have. And those seem to be the 3 things. What I still see slip-ups on, however, for socializing this, is that good old causation is greater than correlation. So what actually caused the failure? So yeah, you can see there's a symptom. That correlates that, the baked beans look this color at this temperature, and we can see that has something to do with frogs. But is there an actual causal relationship between the color of my baked beans at that temperature and frogs? No, there's just correlated out of some rando thing. So you want to actually more related to performance. We see a spike in CPU. that was just rogue. Didn't have anything to do with the function that we are actually debugging. What else happened? So I see at a certain time, we're going to see what other issues happened in other components at the same time. Can we fix the cause? The real thing here is, how much time do you spend on correlation? And do you feel like your stakeholders are actually online with you, in sync with you? So can we get to causation out of correlation? And that's one of the goals of making observability more social. Hey, Bill, tell me what's going on in the database. Mary, tell me what you did in the front end of the web server. Give me some idea of what's happening when we look at all of these data. And Bill might come out and say, oh yeah, that's you did a scan there. That's a terrible index. We need an index. That's one thing. So we fix that, rerun the test. Okay, Mary, now that that's fixed, now we've got this other bug, we'll go fix that. So we can figure out causation leading to other correlations. Observing versus troubleshooting. Observation relates to making things seeable, meaning we can rapidly learn about stuff. We can support a process for reaction, remediation, or escalation. It's expandable to larger audiences, right? Troubleshooting is more focused on taking action once we have seen something, right? So remediating and validating the fix correctly worked. So enable those actions based on the observations. We're actually taking efficient course of action to repair and remediate something. And it delivers maybe new coding patterns as a benefit. So once we observe something's gone wrong, we remediate that, and then we know how to remediate it for all of our patterns for development to avoid that problem ever again. So that's the difference between observing and troubleshooting. They're related, but really your observability comes first, and your troubleshooting and remediation is what comes second. And the last part in socialization is this comment about culture, DevOps being culture. Be inclusive of your performance work, include others in your work, foster curiosity about performance in others. If you see someone who is being curious about performance, have them, enable them to see and learn and fuel their spark or their interest. You can make it safe to be seen as the root cause. If my code was bad, I should be like, this is a learning opportunity. I shouldn't scold or shame or any of that. Don't be negative about it. Computers are hard. Coding is hard. All this rate of change is hard. So have a heart, man. I mean, sometimes these people are working and they're gonna get better because you're helping them see performance as you find bugs. So share the accountability for when you fix stuff, share the rewards. So if you optimize and fix things, share those things together. And that's, you can foster that culture of performance. And Joel, I'll bring it home in summary. Don't just do your monitoring as usual when you're testing. Observe performance during your tests and be more passionate about sharing and following those guiding principles. We have unobservable systems. You can think about when you've been stuck and you couldn't see anything. Well, there you go. Do the opposite of that. And then if you're engineering for visibility, get into tracing and logging and everything and share all that. Do some testing on, do we have test cases around good logging? Do we have test cases around good tracing? Maybe testing test cases for that would be good, and then share everything like crazy. And here's my blatant perf byte slide. If you're not following us, we have perf bytes in Spanish. We have all sorts of different stuff. We have some exciting plans for 2021. And I give you my extreme thanks. I know I'm a few minutes over, but that is observability for performance testers.
And I like it because you put it as observability for performance testers, but it's simple observability, because at the end of the day, a lot of what's going on, you can translate it into metrics that are going to have an effect on performance as well. And I take it even personally from practice tests, where we are a SaaS system and we live and die by the fate of what's going on in AWS. And a lot of what you were saying here are things that we learned the hard way and are things that we do today. And it is. I mean, it's not something that you can say, no, it's for performance. It's simple observability, and we need to understand that for many of us today, it's not performance tests anymore. It's performance of the work that we have and the way to take it in there. And I also like some of the tips. I mean, I like that the part of the dumb locks, because it's true. It's true. We need to have things that are, let's say, more political. You need to find a way of making it simple, or I don't know, simple-minded instead of dumb. But all of that is true in there. We need to go into a break, but there's a question here, and I think it's a legitimate one. And you mentioned some of them, but maybe you want to synthesize it. Which open source performance tools do you recommend? Stuff such as Locust, K6, or JMeter? And even maybe more, not only in the performance, maybe also in the monitoring and analytics sections as well.
Yeah. So first, just my current stack. I'm an old school load runner guy. So switching to JMeter was sacrilegious, perhaps. But I'm a big fan of JMeter, and the only reason being that there's so many good contributors coming from the other. The Flood.io, the BlazeMeter guys, there's a handful of others contributors in the stack that are making the JMeter work much better. And also, thankfully, we have like things better than JMeter Java, a JVM that'll actually generate some load. One of the big complaints a long time ago is Java just wasn't performant enough to run load. And we've solved a lot of that just from the JRE capabilities. So Java for sure. Locust is very interesting. I have one team of mine that works with Locust. One group that I have Locust scripts for is Python based. It has a really interesting sort of threading model way of doing connections and requests. So Locust.io for sure. There's a handful of other in the back of my head. I want to say K6 is the other load one that Leandro, my friend, is working, done some K6 work. There's, if you are more or less committed to doing CI/CD, if your performance tests are actually integrated in the pipeline, you'll see something like Locust or K6 or some of these other smaller tools integrated more easily. JMeter's a little bit of a heavier pull. It's more like a load runner, run a lab, run a large load test. But I combine, in the monitoring side, my combination in the stack is to pull together the influx stack for monitoring. So Telegraph is their sort of general monitoring tool, but they also have the logging instrumentation. So you have a time series database in Influx. So the Influx data stuff, InfluxDB and Telegraph are kind of my two in my kit. There's a couple others. The Elastic Stack is really good. Even Splunk, you can put this instrumentation into. Profiling wise, not in the open source world, but they do contribute in the open source world. There's still the Dynatrace stuff. My current work, we have New Relic. New Relic's got some new stuff that they're working on, which is pretty exciting. So yeah, I think diving deep, there's a couple other wikis out there that actually dig deeper into this, sort of the open source tools. I feel like I'm a little bit stuck. I'm getting itchy to maybe learn some new ones too. So we'll see what happens. Oh, and monitoring observability wise, Grafana is, I'm a big time Grafana fan. It's great.
I actually heard about it. I need to take a look into them. Sounds good. Okay, so Mark, thank you very much for bringing observability and performance testing to the rest of us, laymen. And I really appreciate the efforts in that way. Let me start checking.
Cool.
Here.
And I'll be hanging out in my Slack channel and answer any more questions we have over there. Thank you guys very much.